Cześć wszystkim. I'm really sorry. Hi everyone. I didn't know that I will be on the mic already. Welcome to the last presentation of the day. Congratulations for making it. You're very brave to be here, and I already admire you. So I'll try to make it entertaining and fun. But the disclaimer, after over 10 years of public speaking, I'm still very nervous in the beginning. I know all of the tricks, but I'm really sorry if I get a little bit nervous in the beginning. That's how it works, they say. So I wanted to talk to you today about hypergrowth scaling made simple. And this is about how actually we can make complex systems simple. So I hope you will learn quite a lot during today's talk. And I'm really looking forward for conversations afterwards. So very quickly, for those who don't know, this is Magic, so my dog. And I'm working on a daily basis as a head of engineering and executive director at Revolut. So I'm responsible on a daily basis for Revolut business engineering teams. What are we going to talk today about? So I really wanted to show you how do we make mistakes. And it will be a story that you may actually hopefully recognize quite a lot of different bits and pieces. A second topic that I'm going to touch on is how do we make, what are the complicated and complex systems. So I would like to introduce a mental model, how to distinguish those two, and what we can do actually first, fixing complication in our systems, and then how to work with complex systems. And the last topic that I want to touch on, which is very important, when you scale very, very quickly, there is always a question of technical depth, and everyone is so afraid of technical depth. So I'm going to actually challenge a little bit of your beliefs. But first, a little disclaimer. So I did call for papers. It's not sponsored presentation, despite I'm using Revolut slides. So thanks to the committee for accepting my talk. And opinions are on my own. So do not tag Revolut if you don't agree with me, because I may get into trouble. Then, Revolut, there will be examples from Revolut though, and I'm using them to show you stuff that I will be talking about is perfectly feasible, and it's actually used for a hypergrowth product at the global scale. So, and the last thing that I wanted to add, the key point, so put aside Revolut examples, think about the mental model that I will show you and how you can apply it, because that's the point of this presentation will be the approach that I want to show you. Okay, first let's focus on where does complication come from in our system. So imagine a system design interview for a global fintech. I can give you also a disclaimer. My system design interviewer sits here in the room, and I was terrified when I saw him on the other side of the screen. And it was a very interesting conversation. So be careful what you wish for. So who of you, hands up, had a system design interview? Okay. So for those of you who didn't have it, it's basically speaking, you're being asked questions to design a system, and the system starts at this very simple problem, at a very simple scale, and the complexity and, of course, the scale grows up, and we see when do you break. So that's how it usually works, and how far can you go with your idea. So the problem that we're going to tackle today on our system design interview is e-commerce, paying for goods in the e-commerce store, right? So imagine that I have an e-commerce, I sell, let's say, coffee, and you're going to buy something from me, and you're going to pay for it. In short, the domain problem looks as follows. So there is a buyer, of course. They use a card to pay using their bank account. The money goes to my business, my account, and I can take it, of course, after I send you the goods. To quickly rewind forward, the problem that how you can tackle it is, of course, design a couple of services. So first, I make a payment request to the payment service. That payment order gets to a payment gateway that contacts, for instance, Visa and MasterCard and asks, well, can I use this card, and so on and so forth, just to make things very, very simple. Then, of course, this we're going microservice. So this microservice probably has some sort of a database that we can use to store the data. Then, of course, internally, we need to have an account balance, change the account balance, and we have some wallets. So this is where your money is being kept, right? And of course, this microservice has its own database. And then we have the famous ledger that has, of course, some sort of a database. It's a special database. We'll come back to that. And of course, our service has a database on its own. We're very proud. We tackled the first problem. So the interviewer asks us, can we actually scale to a country level? So we're successful. Our, the few databases through a few hundreds of thousand customers is working really well with our solution, how to scale the system to a country level. And we say, yeah, of course we can do it. So first we can, this is a service that we can easily scale. We'll add some load balancers and we're good. Then, of course, we say event-driven architecture. So we definitely want to shine in our system design interview. And we say, yeah, of course, we'll do event-driven architecture. If you had the pleasure of listening to Andrzej's talk today, it was also talking about what can happen, and we'll come back, touch on that. But we, of course, introduce Kafka, why not? And, of course, we do work with the system asynchronously. I will forget the whole stuff on the right, because there will be far more that we want to tell our interviewer about. So the question will be, okay, let's scale the system to the continent level. So we're successful in our country. We have whatever, maybe 5 million customers. We want to have more. What do? We say, yes, no worries. First, the problem that we need to tackle, because it's a system design interview, we need to think about business problems as well. We say, oh, we have currencies. And currencies service is here. And it's special, so the form of data, so we'll use a MongoDB, for instance. Or maybe, guys from the relational databases weren't available. Then we say, okay, we want to scale even further. We add some Redis, some caches, and so on and so forth. Everything will go smoothly. The next question from the interviewer, okay, fine. What if I want to add new features like notifications? Not a problem, right? We'll add a notification service. Because we're event-driven architecture, we can just add another consumer. And of course, there will be a notification that I'm paying for something. We can start the securing our payments as well. And that where the question will come, okay, what about fraudulent transactions? So there are, of course, bad actors in our system. They want to use our bank. They want to exploit it. They want to steal. Basically speaking, it always happens with if you have some sort of value in the system. And we say, of course, we have an event-driven architecture. We'll add fraud detection service. It connects to the public, for instance, the public data. And we have, it's very smart, it uses a graph database. So, of course, we need to understand all of the connections between people. How do they interact? What do they spend the day, their money on? Where, and so on and so forth. So we're introducing another database. And we say, oh, I worked with Hadoop. So, Mr. Interviewer, here comes my big data. And I will dump all of these events to my data lake, and I will use some sort of ETL mechanism to actually have machine learning models that will produce events to our fraud detection system. So the system is getting smart. And we don't stop there. We're seeing the smile on the interviewer's face. And we introduce even more. So we say, actually, we would like our system to be real-time data. So we want to act on every single event not micro-batching, as Spark, of course, has. So we're introducing yet another technology and yet another database, because it needs to be fast. And we say to our interviewer, this way, we'll make it work very, very quickly. This is optimized for the kind of data we have, and so on and so forth. Perfect. We did it, right? Are you proud of our design? Yeah, okay. And the interviewer asks us, okay, let's go global. So 5 continents, and our bank is actually going fully global. So what would you change in your design? So just to remind you, this is where we started. So first of all, we say we have Kafka, so we had Kafka mirroring between data centers. Hands up if you did it. Okay, yeah, you're safe then, and you know where you don't know where the pain is. So good for you. You didn't have to do it. But then we don't stop there. We say, of course, we will be scaling data. So we introduce the clusters. Some, of course, we will say, yeah, we can just multiply databases as much as we can, as we want, right? So we'll just add more and more clusters. And of course, we will say some databases will scale themselves. And here comes the interesting question from the interviewer. What about distributed transactions on a global scale, right? And we say, no worries. We have event-driven architecture, and we'll introduce Orchestrator with its own database, and we will be able to handle the distributed transactions. You know where it's going. My, poor guy. And then we ask, okay, so we have a ledger, as a question from the interview. We have a ledger, how to scale this. And you may have actually noticed that the color of the database has changed. It's very important. And we say, actually, we want to add 2 more things, atomic clock and the GPS. Can you tell me what I've just used? Yeah, there was one good guess. It's a spanner. So, of course, Google solved this problem, adding atomic clocks and GPSs. And by the way, this is phenomenal paper. I do recommend reading it. So it's a piece of really a spaceship technology that you can use. So we say to the interviewer, we're done. Interviewer says, thank you very much. That was a great interview. Congratulations, and good luck with the rest of your interviews. Right? And we finished the call thinking we did it. And we're actually very proud of our design. So the question is, do you know what we've just done? We just made a very complex system, very complicated. So you can see how many different components are introduced to solve the problem that I've shown you. So let's start with thinking, okay, what is a complicated, complex system? And a complicated system, complex system, I want to actually introduce the system thinking mental model to show you how we can approach such a type of the systems. So there are several books on the topic. The one that I will truly recommend is an introduction to general systems thinking by Weinberg. You should know the author. He's like super productive with writing books. So there are plenty of the books that you can actually get from this author. Okay, and then system thinking Weinberg introduces 2 very interesting concepts when it comes to systems in system thinking about complicated systems. First is randomness. And randomness are all of the factors that actually make your system less predictable. So anything that will make your system more predictable introduces randomness. So this is one factor. Stay with me. Second factor is complexity. And Weinberg says complexity is actually something naturally in the systems, because it comes from a number of relationships, interactions, and computations that were required to change the system state. So how do we understand that? Well, he proposes to put that on this chart. And there are two, as you can see, two factors, three types of systems. First is organized simplicity. So these are very trivial systems, very little randomness, right? So it's predictable, in other words. So we know how it works. These are very simple systems. The mechanics are really well known. Second part is on the top. So I'll go actually from this perspective. Second part is on the top. The systems are so unpredictable that we cannot really understand what's going on inside the system. So it's from the outside is often pure chaos. And our job then is to actually lower the randomness. The third type of the system is organized complexity. And this is, from my perspective, where all the fun happens. So it's medium randomness and medium, very often medium complexity, but still it's too complex to solve with simple mechanics. So we'll touch on these systems. So how do we introduce randomness, which is pretty much the complication of our system? And from my perspective, when I observe different systems and charge it as guilty as well, is we have three sources of randomness and therefore the complication in the system. First is tools. The more programming languages, the more frameworks, libraries, cloud services, external services, you name it, the bigger the randomness. Think about this. How many layers of abstraction there is between the silicon CPU and the user interface, and how much we still add to the equation, because just for fun it will be more convenient for us, or this is a type of a database that it will suit our case even better. So the first one is tools. Second, from my perspective, is processes. So if you have a system that you work on, whether it's an app or part of the app, the more different processes you have, the more differences in the processes you have, the bigger the complication will be. So for instance, my favorite is, let's make all of the teams agile and autonomous and let them choose how they work. It's like asking for trouble straight away. I mean, of course they will work the way they want, but the problem, they will slow down because all of the differences between the teams, right? So it's not a proper way to do it. Then the third one is differences in skills. So if you have one team, the bigger the difference between the skills, and meaning the understanding how we should work on the system, the bigger the randomness. Because of course, different people will work on the same task differently. Then an outcome, of course, is more and more unpredictable. So these are three sources of randomness. And from my perspective, when you look at this, the bigger the randomness, the bigger the complication of the system. As simple as that. So this is the first outcome that I would love you to take from this presentation. And simple things should be simple. Complex things should be possible. That's Alan Kay, and I'll come back to that. What's the Revolut's approach? And this, for me, that was mind-blowing when I joined Revolut. So Revolut's approach is make architecture simple. It is mind-blowingly simple. I will show you that in a moment. So second is introduce simplicity standards. So the simplicity standards are enforced. So when you design a new system, new feature, you need to actually have architecture design reviewed, and you need to have, it will be criticized. Why do you want to introduce this A, B, C, and D, et cetera, et cetera. Third, shorten the feedback loop. So the sooner we learn that we make mistakes, the better. So, of course, this is like TDD, automation tests, monitoring, SLAs, mean time to recovery, and so on and so forth. So the shorter the feedback loop, the better. To give you a glimpse how Revolut actually works, I would say it's very, very simple. So it's basically speaking as every other technology company of the current age, right? These are microservices. And pretty much nothing else. No fancy stuff, I would say. And Revolut really focuses on those. The rest is fully solved by the vendor, which is a Google Cloud Platform. So networking is really good with Google. The rest, I'm not a Google employee. I can say it depends. what you use, right? So what are the architecture components? So first and foremost is vanilla Java services that uses, I wouldn't call it like a fully DDD framework, but a DDD tooling that helps you to have some concept that you can very quickly reuse and have abstractions that really help to work you with the infrastructure of Revolut. And that's pretty much it. This is a pure Java code, so no Spring Boot, Lombok, etc., nothing. So it's pure Java. Java 17, by the way. ML models with our Python services and Kubernetes clusters. And this is on the application. These are the applications, period, nothing else. Data analysis and modeling, I don't want to get too much into the details, but this is done purely, I will have a slide on it. Our own feature store that we developed that helps working with the infrastructure that we have, that has several functionalities that actually accelerate data teams very, very nicely. They're very interesting, and I think that what was mind-blowing for me, and Andrzej gave you a glimpse that it's very interesting. Revolut did everything on the Postgres, including even store and even bus. So Postgres is actually a very powerful database, and it works on the scale of Revolut. Mind you, 27 million customers at the moment, active customers, 500,000 active businesses, so B2B banking accounts, and it works. Analytical databases, Redis as cache, object storage, period, nothing else. No Kafka, and you call it, right? Document databases, nothing else. And networking services. And this is it. As simple as it could be, to be honest. I mentioned the standardized simplicity standards. So there are like guidelines and playbooks that you can use to design your own services. So that they're ready to use and you can go after them. The feature store is fully aligned with the service topology and enables pretty much everything what data science team needs to use. So it comes with everything out of the box. It's just yet another service that we had to develop. Of course, there is a team that supports it, but actually it's very powerful. And this is the numbers to prove you. Such a simple approach works on a scale. You don't need anything fancy. So it's very, very powerful scale. Now the question, how many people build and support Revolut's architecture? I'm asking about sysops, so guys that do the infrastructure. Hands up, and yeah. 30, 10, 5, yeah. That would be extreme. It's a global bank. 15, so it's a team of 15. And I'm also sometimes meeting people from other banks, like typical banks. They pretty much have whole divisions in every region or every country, because there are, basements full of whatever there is, Hadoop, maybe Odra. So it depends on how modern the bank is, right? By the way, no QAs in the company, not a single QA in the company. So you can do it very, very simply. You can have the quality that you can rely on, and you can do it very, very simply. Furthermore, there is only dev and prod. I didn't put it on the slide. So it's like engineering done well. If you feel uncomfortable pushing something to the repository, good, you should, because it's going to the production very, very soon. I do recommend the presentation power of simplicity from Alan Kay. It's a must, to be honest. So take a picture of this presentation. It's really, really powerful, really eye-opening presentation. Okay, I wanted to talk about dealing with complexity. So we touch on complication and randomness, so how we make our system complicated. Now, okay, you can tell me, okay, Wojtek, but still, some processes are complex. And yes, they are. We want them to be complex. according to DDD, actually, we want our core domains to be complex, because the more complex they are, the harder it is to copy, and the more successful we are. So how to deal with this? And in the company, there is this idea that, first of all, which is called the bets, right? So you set up the new team, you have 1-2 quarters to deliver, and if you don't deliver, you just leave it, right? So you just walk away. It's okay. It's, as maybe on some talks we heard, it's really sad to work on the feature that is not being used. It's you can use your life, get your life far more productive and more fun than working on the stuff that is not being used. If it does work, then I would say leverage systems thinking and DDD, and that's a mental model that I want you to try out. So 3 types of systems: organized, simplicity. So as we said, these are very often type of problems that are well understood, well organized, and we can very simply explore them, understand them. So I would say use basic domain-driven design techniques. Always use I would say, if you're building a business product, pretty much you can always use the strategic DDD and benefit from it. About the tactical, it's your own preference. But ubiquitous language, of course you want to use it, and always make sure that you use it. So there are a couple of things that I would suggest. First of all, make sure that you understand how simple everything are, simplify it even further, use basic DDD tactical patterns if you want to, they will help you, and use the principle of last astonishment. So this is a principle where you don't want to create function lists that increase friction in your interfaces, for instance. So as smooth as possible. So these problems, we do not overcomplicate, we do not over-engineer, we do not over-design when it comes to UX. Unorganized complexity. These are really interesting problems. This is where very often our business stakeholders come to us and say, can you give me an estimate for this? And you open the brief and there is pretty much nothing. And they say, by the way, you have a quarter, right? So this is sometimes happening. And you don't know what it is. So very often it's too big, too complex. It's sometimes we underestimate how many different moving pieces we have and how many different moving pieces we need to organize. From my perspective, break it down, decompose, we'll use whatever technique works for you. I like even storming myself, but you can use whatever works for you. Divide and conquer, right? So make sure that you can start to design the system, divide it into bounded contexts ideally, then you can apply different patterns, of course, and then you can make sure that you tackle the parts of the system one by one. And of course, you can use some more advanced DDD patterns and techniques. They will help you to keep the complexity organized. So if you haven't worked with, for instance, context mapping and anti-corruption layer, but you have a problem like that, it's a time to open the book, educate, and they will bring you some ideas how to solve your problems. And of course, happy to talk to you if you have any questions about this. Organized complexity. So from my perspective, these are the most interesting problems, like very interesting, complex business features where we need to really think about what we're doing and when we need to really carefully design our system. From my perspective, there are only a few things that I would truly recommend, like making sure that you use the ubiquitous language. You understand the different dependencies in the system, external system, actors. So this is like, you can apply like fully blown DDD as much as you want. By the way, DDD is a toolbox, so you take whatever works for you and for your team, right? So this is what I would recommend. There is a very interesting talk that I would like to recommend on the topic, is on the complexity and how to work with complex system. Is a residuality theory by Barry O'Reilly, done on the last DDD Europe. So you may actually find it very interesting. He has a theory how to tackle such systems. Okay, third thing, legacy and hyperscaling fast. So We talked about a nice approach, keep simple, etc. But there comes the business, and God help you to have such a business that will tell you, push. We're really getting the momentum. We're growing exponentially. This is an interesting moment. So what happens? And I would say when you scale ideas fast, the question is, what do you want to optimize for? We're terrified of technical debt. We're terrified of having legacy systems. So I would like you to, and we always love this refactoring sprints, for instance, and making sure that our systems are shiny and beautiful, and our Sonar Cube is so green, and everything is perfect. I want to challenge you on this. Depends what you optimize for. If you want to hyperscale, optimize for speed, not for green colors on your metrics, on your code. Why? Because if the rate of change outside of the organization is higher than inside the organization, you're in trouble. And by the way, with the latest developments in our profession, the rate of changes outside will accelerate. So I would recommend go back to your code, go back to your solutions, think how you can actually optimize those systems, because everything is going to go crazy very, very soon, right? So legacy at speed. From my perspective, the bigger enemy of over-optimization, over-design, the bigger enemy is not the technical debt, it's over-optimization and making some of the bounding decisions too soon and too quickly. To give you even more recommendation, is from my perspective, what works the best, defer decision until it's painful. Like truly painful. It's not like my eyes are hurting because it's not a clean code. Defer it until it's painful, right? So it's actually, you will benefit from it, and I will show you how and why. Our most important job, if you are a software architect or a senior engineer, I'm really sorry, I don't want to talk about seniorities. If you make decisions on the architecture of your solutions, it's actually not to code. It's, I would say, it's actually deliver as quickly as possible, and of course, eliminate irreversibility of your decisions, because you want to be challenged. When you go fast, the product changes very, very quickly, and you want to be able to change those decisions. But at the same time, I would ask you, what happens if we get a new project? So, or when you change a job, or you get funding? What happens is that we look like this, right? So we love the new problem, we love the new solution, and we always come up with big design up front. That's a lovely anti-pattern. So we have these meetings and whiteboards full of what we'll do, what we need to focus on, etc., etc. Why is it a problem? Because first of all, you make a lot of inaccurate assumptions and collect inaccurate requirements. Very often you don't know about how your users are going to use your product. Or even, I would challenge, you don't know how they're using your product. But still, you're making a lot of assumptions. That's a whole other topic, but please think about how do we gather knowledge. So only a few bits that you measure and you know about are known knowns. Everything else is you don't know that you don't know, or you think that you know, but you really don't know it yet. Second the problem that comes from that is lack of adaptability. So even if you learn something new, a new fact, it will be very hard to reverse it. So we come back to our business and say, yeah, we would do it, but we need to pretty much rewrite the whole part of this system, right? So this is the thing that happens very often if we do too much design up front. And I would say it all ends with, of course, increase in investments, cost, time, efforts, and I should add, burnout. You very quickly burn out with systems like this. Okay, so deferring decisions, I want to emphasize, it's the more uncertain you are about the product, the more you will gain from deferring the decision. You can call it the Wojtek's law of differing decisions if you want to. So this is my thesis for this part of the talk. There is an excellent book by Gregor Hochberg. You can actually recognize him from Enterprise. Help me. Exactly. So he did 2 amazing books. This is the new one. There is a whole chapter on how to defer decisions and how actually you can measure deferring decisions, how much you can gain from it. Second, another thing that I wanted to add with big design upfront and what we do often as software engineers. What do you see here? Features, yeah, but what do they have in common? I mean, what this system, what do they have in common? Booking something, exactly. So you have something that has time availability, and you book something in time with a certain availability, right? So these systems are actually pretty much the same. They use exactly the same patterns. And there is a concept in software engineering which we forget about called archetypes. And we forget that we pretty much designed a lot of things in our systems already. Banks exist, well, longer than computers, right? So a lot of patterns are really well researched and documented, and you can actually benefit from it. So talking about banking domain only, here are the books that you can use as patterns catalogs, open and see money, transfer, invoice, what else, employer, payroll, etc., etc. You don't need to redesign stuff. If you work on something, you can actually, take the wisdom of the elders, because these books are like 20-something or more years old, and actually get many inspirations. You don't need to redesign them, reinvent them. So another talk that I would definitely recommend is domain-driven design strategies for dealing with legacy systems. This is like, over 10 years old talk, but still very relevant, and you will actually benefit. There are some very interesting ideas that you can get from domain-driven design. I would say Revolut's approach, because I promised that I will actually talk about how you can make it useful with the example of Revolut. So first of all, create the smallest thing that is that delivers the business value if you're working on a business product, because you may not. But if you're working on a business product, deliver the smallest thing that delivers value. Then make sure it is used. Very often we deliver something, look at Google, and we don't look at if it's being used. Third, focus on commercial success. So I'm heading a Revolut business, and I can tell you every single product team has business and commercial metrics, and they're responsible for it. So I, as an engineer, I'm responsible for commercial success of my feature. And Jarek will tell you differently tomorrow on the bare metal talk, and he will ask you to optimize everything from on the CPU and memory level. But I would say add CPU, add memory. Don't care about this, because actually, if you want to go really, really fast, this is a cheaper way of addressing issues until it really hurts you. When it hurts, make one of 3 decisions, I would say: refactor, rewrite, or create new product. And we very often make these decisions too soon, and we forget about actually a very interesting options that we have. So first one, we love that, is refactoring. We want to make the inside better without changing the outside. Second, we also love, it's a rewrite, right? So this time we will make it better, quote, type of the approach. But I would recommend the third one, which is really interesting, and we forget about this. Let it be. Let it be painful even, but learn about the product, because actually there might be a chance that you will learn that there is a new business opportunity, and actually your product is 4 different products, and you can forget the first one, by the way. So this is what can happen quite often, and I would truly recommend this sort of approach. And another thing that I would recommend, of course, is to make sure that you get comfortable with pain. A lot of people are not comfortable with pain, and eyes hurt when they see not a clean code. So I guess if you want to go really, really fast and scale very, very fast, you need to be, you need to get comfortable with this. And I would say the last thing, get stuff done. I really should have another 15 slides. What Agile did to us as a profession, because we have excellent frameworks to have retrospectives why we haven't delivered. I don't care why you haven't delivered. Get it done. So make sure that you actually deliver it to the production and make sure that you're responsible for it. So remember about this, because we're so spoiled by all of this. I shouldn't say that, but people who run retrospectives, that we're, you know, why you haven't delivered? Well, what could you do better about this? Well, I could deliver, period. Summary. Whew. I got nervous a little bit. Keep simple things simple. So from my perspective, think about how we design our systems. If you next time when you have the great idea of or a new product to work on, I would encourage you stop that racing car in your head that tells you, oh, there is a new technology, new database, new framework, new version. I really need to try this. Stop it. Just use the simplest possible, and remember about the mental model that I wanted to convince you to leverage the systems thinking. So think about what problem are you solving, and then apply known patterns, known tried and trusted patterns. Then force yourself and your team to introduce simplicity standards. So make sure that you have such things. They can be playbooks, they can be contracts. There is a whole concept of evolutionary architecture that you can benefit from. And you can have, for instance, fitness functions to make sure that you make the right decisions. And for God's sake, do not introduce, of course, more randomness. And the third thing, defer your decisions. So know when it's worth to refactor, get comfortable with the pain, but even if you think that it's good to refactor, ask yourself a question, do you really have to? Try, add the CPUs and memory, and of course, go for Jarek's talk tomorrow. But remember, if you want to scale really, really fast, you don't always need to optimize for every bit that you send over the network. Sometimes it's way more beneficial to go really, really quickly deliver the business value. With that, thank you very much. I will have, of course, time for questions. But first, Sebastian talked about this. This is a mini community project that we run with Tomek Onyszko and Sebastian Gemski, who was speaking today. And if you would like to talk about actually topics around engineering leadership, especially for senior engineering leaders, you want to connect with like-minded people, hop on, connect with us, and we're planning actually to do something with this project further. So it would be lovely to connect. It's sometimes lonely on the top. Remember that, but it doesn't have to be. So thank you very much. You won't find me on Facebook, but you will find me on LinkedIn and Twitter. Yeah, ask me any questions. I'll be, of course, at the party. No. You have it. Okay, perfect. How to deal with inherited legacy monolith component created in early stage when you have a hyper-growing and having new microservice system? Okay, that's a very good question. One of my main projects, I can actually be quite open about this, is modularization of a huge monolith, over 2009, well over 2009 points. So it grew so much, and we do actually modularize it at the moment. So there are different techniques, and I would say it really depends what you optimize for. But I would say in this case, we could show that actually it delivered the value and it scaled until a certain moment, until it was very painful for us, for instance, to deliver it to the production, mean time to recovery, for instance, metric. And we decided now to modularize it. You can do it differently. So I would strongly suggest to very closely observe what's your business landscape. If maybe there is when you scale and grow your organization, very often you start as one unit, but there will be different units. And of course, here comes the Conway law as well. So depending what are your organizational units, I would very closely look at what will actually make us faster. And if actually we want to grow some teams faster, communication becomes the issue, dependencies becomes the issue. So for instance, CI, CD issues going together to the production becomes an issue, then I would make a decision to modularize. I hope I answered the question. If not, please raise the hand. Why not use Kotlin? Whatever works for you. So if you have a team of PHP engineers that are truly comfortable with MySQL, go for it. A lot of very big projects were built on such a stack. So if you want to use Kotlin and everyone in the team is comfortable with it, perfect. So I would say what works for the team, but remember about how do we introduce the randomness and complication in our systems. If the whole team ideally is capable of using the certain chosen language, and the skills are pretty much on the same level, yeah, let's do it. When you are developing a new feature, do you think how it will impact the whole product synergy? Yes, and here comes I mentioned that when you design a new feature for instance, in Revolut, there is a design review committee, and the role of this committee is to challenge your design decisions and to challenge you to make sure that it's simple as possible. So this is how it's done in Revolut. I would, if I were to design an organization from the scratch, I would make sure that actually we have the same and we have different people to challenge ourselves. So we have design creeds. Our UI UX designers have design creeds, but we don't have enough criticism in engineering. So I would say too many decisions are made by people who we consider, the most senior, etc., in the organization. Sometimes asking the right question is very important. So I would encourage you to have a culture where you have a process where you can have a system design critique, and you can actually criticize anything, right? Ask anyone to criticize it, to ask questions and to make it better. Furthermore, what I'm also lately experimenting with the team, we're doing post-mortem critiques. So in other words, when there is an incident, there has to be a post-mortem. And if there is a post-mortem, there is a group of people that criticize the post-mortem. So try to find any mistakes or things that we forgot to challenge in the post-mortem. So I would encourage us to criticize as as engineering teams even more. There are no other questions. In Revolut? Yeah, yes. And it consists of senior engineers in the like lead and directors in the company. No, it's the committee is big enough to actually make sure that it's as smooth as possible. Does it differ sometimes your decision? Sometimes yes, but it really depends on the system. Thank you. You made it to the end of the day.